This analysis discusses a Mulberry project, a critical logistical and technological operation during the Normandy invasion in June 1944. The project involved constructing two artificial ports, Mulberry A American, Mulberry B British, designed to facilitate the landing of troops and supply. These ports were larger than the port of Dover and were assembled rapidly on the Normandy beaches after a 7-month manufacturing process in the UK. The port structures include Phoenix caisson breakwaters, floating piers with pontoon bridge, equipped with piles and floating roads called wells for motorized transport. Design considerations account of weather condition, tide, and coastal current, with a minimum depth of 18 feet for ship entry. The video or the guided tour highlight the manufacturing of concrete structures, pontoon deployment, and the use of bombard and steel breakwaters, which face limitation due to the adverse weather. The success of the project depends heavily on logistics, including transportation and installation, which face challenges such as the shortage of tugs and weather disruptions. The June 1944 storm severely damaged Mulberry A, leading to its abandonment, while Mulberry B, despite sustaining damage, continued operation thanks to the bravery of its crews. The port's strategic importance was vital for the invasion's success, enabling the delivery of 25% of Allied supply by October 1944 and played a key role in Europe's liberation. The conception and preparation of the artificial harbor, Project Mulberry. At the end of 1943, the final decision was taken to build one artificial harbor, codenamed Mulberry, as part of the effort to support the Allied invasion in Normandy. As soon General Eisenhower became the Supreme Commander of the Allied forces late 1943 and visited UK in early January 1944, the final decision of building two artificial harbors been signed. One harbor, Mulberry B, would be built by the British at Arromanches, while the American would build Mulberry A further west at Omaha sector. Each harbor was designed to be larger than Dover Harbor, which itself had required 7 years to build under peacetime conditions. In contrast, Mulberry had to be prefabricated in just 7 months and assembled in Normandy within days. Brigadier General Sir Bruce White had been overseeing port engineering since the early years of the war. White was a distinguished civil engineer with experience in both military and civilian contexts. His company was specialized in transport systems and port engineering. The Mulberry harbors were composed of three main elements: breakwaters to provide sheltered water, piers and floating quays for unloading ships, and floating roadways connecting the pierheads with the land. These roadways allow motor transport and fighting vehicles to move efficiently from ship to shore. Additionally, the beaches protected within the arms of the breakwater became usable in all weather conditions for the rapid deployment of amphibious vehicles such as ducks. The bustling activity of these vehicles in the harbor was compared to the busy streets of London. The breakwaters consisted of enormous reinforced concrete caissons, known as Phoenix units, and sunk block ship called gooseberries. These structures protected the pierhead and shore arms, providing calm water for mooring ships and overcraft. Further out to the sea, giant steel booms, bombarding floating breakwaters, added an extra layer of defense for the harbors. 3 additional beaches added to the project later were protected solely by gooseberries. The code name for 3 components was selected at random, and held no particular significance except perhaps for bombardment, which was intended to suggest a connecting to anti-aircraft defense as the cover story. The block ship, blasted with concrete and scuttled by explosive, were reinforcing the Phoenix blocks. Most of the Phoenix measured about 200 feet in length, just over 53 feet in width, and up to 60 feet in height. But some were smaller, with the smallest being 174 feet long. 7 companies and consulting engineers were tasked with supervisions and constructions of the caisson. This included Oscar Faber, Sir Alexander Gibbs, and partners Sir Cyril Kirkpatrick, Randall Palmer and Tritton, Al Crow and partner, White and partner, and a group including Mitchell, Vagnity, and Quell. Since the caisson needed to be floated out, it would have been preferred to build them in dry docks. However, dock availability was limited due to the demand of shipping and the bombardment breakwaters. As a result, alternative construction sites were found. Graving docks at Tilbury, Gourock, Middlesbrough, as well as the vast East India and Surrey commercial docks were used. Some of these docks were drained for the first time in over a century, raising concern that the wall might collapse due to the unbalanced water pressure. Indeed, such a collapse did occur, reducing the capacity of certain dock sites. Additionally, caissons were constructed on beaches near Portsmouth and launched down slipway, while several sites in the Thames estuary were also selected. Their caissons were built in temporary excavated basins and flooded out when partially completed. In total, 213 units of various sizes were constructed, with 147 needed before D-Day, and the remainder required in the autumn 1944 to strengthen and extend the life of the harbor. The War Office team, working with designers from several consulting engineers and other sources, was responsible for the design. The key aspect of the caisson designs were robustness and simplicity. The caissons were to be plain and symmetrical without angles played or gussets. Reinforcement consists almost entirely for strength bar, usually without band and hooks. Large opening in the cross wall reduce weight and help keep the center of gravity low. Vacillating, towing, and swinging, provision for crew quarters and gun mounting were included, albeit in a primitive fashion, and additionally challenge was that construction, experimentation, and modification were occurring simultaneously, so any changes from testing had to be quickly incorporated during ongoing work. Each constructor chose their own method based on the facility and material available, as well as the skill and availability of laborers, much of which was unselect in experience. Approximately 20,000 men were directly involved in caisson construction, not counting those working at oversights. The casting of the caisson began in December 1943 and was completed within 150 days. The first caisson arrived at Arromanches on D-Day +1. This called for 3 piers at Mulberry A and 4 piers at Mulberry B. The pier heads needed to rise and fall with the tide, allowing coasters to unload at any tide stage directly and rapidly onto vehicles. The short arms were floating roadways, enabling vehicles to quickly reach the beach. The breakwaters were essential for forming a sheltered haven, but the true effectiveness of the harbor depended heavily on the piers. For maximum utility,
the piers had to ride with the tide as demanded by Churchill. To meet this requirement, Bruce White drew on a design of a type of dredge invented by Lucknutz and companies of Rheims. This consisted of large rectangular pontoons with load-bearing piles, spud, at each corner. Once the pontoon was in position, the piles were dropped to the seabed, and the pontoon was jacked up to rest of them, forming a stable working platform that became the pierhead. As built, each pierhead measured 200 feet long, 60 feet wide, and 10 feet deep, with accommodation for the crew. 9 of these were positioned at the head of each pier. At Mulberry Bay, one pierhead was adapted to allow landing craft to unload directly by lowering their ramps onto special pontoon, which sped up and floating and reduced the risk of damage to be craft by avoiding the need to beach them. The pontoon, codenamed Beetles due to their distinctive shape, measured 42 feet in length, 15 feet in beam, and were 8 feet deep. Due to a shortage of steel, some of these pontoons were constructed from precasted concrete with a skin thickness of 1.25 inches, while over were made from steel plates. Despite expectation, the concrete pontoons proved to be the most fragile under operational condition. By January 1944, the numbers of required pierheads has been increased to 23, with a few designated as spears. The total length of floating roadways expanded from 6 to 10 miles, including 3 miles of spears. The expansions required the fabrications of 120 spans, each 80 feet long, and 8 shore ramps. In total, about 670 pontoons were needed, with 470 made from concrete and the remainder from steel. The pierheads alone required 60,000 tons of steel, while the short arms needed another 30,000 tons of steel and concrete. Prefabricating was distributed among 300 firms for the pierheads and 250 for the roadways, involving a workforce of 15,000 men. The quality of work varied widely. While some firms delivered high-quality component overs, particularly among the concrete manufacturers, had little relevant experience, with some previously making only fence posts rather than water-tight pontoon. Wherever possible, welded construction was under to save steel, but a shortage of skilled welders meant that much of the work was done by individuals with little or no prior experience. This contributed to delay in the construction schedule, much to annoyance of the American partners. Nevertheless, by mid-May 1944, 14 of the 23rd required pierheads were ready, and all but one was completed by the end of June. Transportation and assembly challenges. After manufacturing, the harbor components had to be towed and transported to assembly point on the south coast of Great Britain in readiness for the Channel crossing. One of the primary challenges was a shortage of tugs for towing. On the eve of D-Day, only 132 tugs were available for Mulberries, and just 108 were available for towing the various components, including Phoenix blocks, bombarding breakwaters, and Wells units. The shortage of tugs and mooring places, many of which had been requisitioned by the Admiralty for their bombardment, created further complication. As a result, some caissons had to be temporarily sunk in shallow water and then refloated when needed for transport. While most assembly sites were adequate, a small number of caissons were damaged during this process. This operation proved challenging for the Army, as it was outside their usual experience. U.S. Navy Salvage Officer Commander Edward Hellsberg quickly identified that the Army's pumps were inadequate. All through, some British officers found his criticism harsh. His advice to hand the task over the naval salvage expert, preferably U.S., was largely followed. British salvage expert Mackenzie, known for raising German battleship at Scapa Flow, was given charge with discreet input from Ellsberg. By May 27th, the situation was under control, but the series of misshapes delayed the anticipated completions from D-Day plus 14 to D-Day plus 21. The main cause of delay, however, remained the shortage of tugs. Nevertheless, Admiralty salvage expert Captain G.B. Poland was able to report with pride that the initial invasion required would be met by D-Day plus 3. Once the Allied army had gained a foothold in Normandy by the afternoon of D-Day, the Mulberry force set sail, crossing the Channel in a varied fleet of vessels ranging from motorboat to paddle steamers, with the headquarters aboard the Clydal paddle steamer Aristocrat. The British Mulberry B sites in the Arromanches experienced little opposition as the vanguard moved from Sword Beach along the coast. In contrast, the American faced much tougher conditions on Omaha Beach, where Mulberry A was to be located. The heavy fighting and numerous defensive obstacles delayed the start of harbor constructions of 4 days for the U.S. The initial task includes supplementing pre-invasion survey information, marking out position for piers and breakwaters, and sinking block ship to form breakwaters. The block ship were sunk using explosives, which misled the Germans into believing their artillery was more effective than actually was. Despite some losses to enemy fire, most block ships ended up roughly in the right position. The 2 Gooseberries block ship breakwaters at Mulberry A were completed within a week of D-Day, but gaps reduced their effectiveness. When a storm struck another week later, the Gooseberry at Mulberry B was realigned due to the unexpectedly deep water. The other 2 Gooseberries were located further east at a small harbor and at extreme left of the British landing. The use of block ships on such a scale was unprecedented in naval history. While some criticized the sinking procedure as too slow and insufficiently powerful, the Admiralty maintained that eye hole were intentional to prevent ballast from washing out. Despite this criticism, most block ships survived the storm on June 19 to 23rd, except for serious losses at Mulberry A, the most exposed harbor to bad weather conditions. Installation. The bombarding breakwaters forming the outline of defense were completed by June 17th at both harbors. Each breakwater was a mile long, consisting of 24 units. Unusually, the layout was changed from double to single lines, likely reducing their protective effectiveness. The bombardment were also anchored in water much deeper than designed, often half again as deep, or nearly twice as deep. While they provided protection during the vulnerable construction phase, they ultimately failed, and the designers understandably felt their work never had a fair chance to prove itself. The Phoenix blocks forming the inner breakwater began their journey across the channel on D-Day plus 1, with placements starting on June 8 at Mulberry B. The plan was adjusted to provide more sheltered water, and by June 18th, 25 caissons were in place, with all but one correctly positioned. Again, deeper water than anticipated was encountered, a recurring theme. Placement on Mulberry A was initially hampered by hostile gunfire, but by June 14, 32 blocks were in position. piers and pierheads. But the harbor could have functioned without the piers and pierhead, like later on in Omaha, by ferrying supplies directly from the ship in sheltered water to the beach via landing craft. The essence of Mulberry Bee was the ability to unload ships straight onto the pierhead and along the piers. They were the most elaborate structures in the systems, and positioning then was arduous, even in the relative calm within the harbor. At Mulberry Bee, units led by May and Colin alongside the tireless American Seabees worked days and nights to stay on schedule. Cohen later reflected that during the day, the site was remarkable sights apart from the concrete caisson. The sprawling spud pontoon pierhead stretched out impressively, and the piers continued to grow within the harbor. Behind the breakwater, destroyers and massive battleship patrolled the coastline, firing salvos and land. Nighttime operations were enabled by a dense smoke screen, with numerous anti-aircraft guns positioned on high ground around the growing port, thunderously defending against enemy aircraft. The atmosphere was described as living in a mad nightmare. The spurred pierhead were equipped with Swedish Oerlikon guns, and Ted Whitcomb diligently trained his men in their use following a strongly worded complaint from the captain of the HMS Rodney. As a result, pierhead's gunners received as more dangerous than the Luftwaffe were forbidden to fire except in their emergency. The pierhead could accommodate ships up from 300 feet in length to 200 feet in width, and with a draft of 20 feet. The spurred were driven into the seabed, lifting the pontoon partly out of the water as the hull was relieved by spinning up 6 inches, 42-ton press down on each spud, and each could handle up to 84 tons when the pontoon was lifted for 12 inches or negative floating during severe weather. Each spud was raised by a 20-horsepower winch using reduction gear, operating twin wires ropes connected to a winch barrel and the spurt keeper. Electric power for anchorage was generated by 257 kilowatt diesel engine and generators. To absorb the kinetic energy of ship berthing in the pierhead, a specialized fender system was needed. Heavy concrete fenders were impractical, as they would have required structural change to the spurt function to withstand the transferred forces. The solution was the Becker fender, designed by Professor Al Becker and described by Richard Cavalry. It was crucial that the unit were linked to the, in addition to those in direct contact with the berthing ship. A gents unit also absorbed some of the kinetic energy. The system relied on the calculated methods of linkage to ensure the safety of the spud pontoon. Faced greater challenges in building their piers, enduring frequent enemy fire and losing some tugs during the crossing. Their first tug arrived on D-Day +3, but it took another 3 days before they could begin positioning the piers. The Seabees, primarily combat engineers, had limited time to train with the equipment less even than the Brits, and some failed to thoroughly secure the float despite Beckett's advice and costly mistake. The harbor at Arromanches, known as Port Winston, operated from June until mid-November, exceeding the original plan of 90 days. Older ports, such as Sherborne and those in Brittany and east of the Seine, took longer to become operational, making Port Winston the only sheltered harbor available between Cherbourg and Le Havre during that period. The storm. In the 2 weeks following D-Day, over 20 divisions, more than 1 million men, went ashore, overwhelming local enemy forces. Yet, ensuring supplies and reinforcement remained essential, and the nature intervened once more. Weather had already delayed the initial invasion, and conditions continued to challenge operation. On June 16th and 17th, rough seas halted towing, forcing a concentrated effort the next day to compensate for the lost time. As Phoenix units and 23 whale spans set out for the beach from England, worsening weather led to the lose of 11 whale spans in transit and 1 Phoenix unit running aground. Fearing further deterioration, Colonel Raymond Mays issued emergency order mooring were to be doubled. Piers secured as far as possible. Ships moved clear of breakwaters, crew readies, and Turks provisioned with fuel and ration. The situation was totally out of control for at least 2 days. Even during the worst of the storm, the Mulberry Bee was still operating. The sappers managed to offload vital stores and ammunitions, landing 800 tons on the piers at the worst day, as Arromanches was not exposed as badly to the storm as Omaha. Omaha could not do anything during the 2 days. Still, at Arromanches, more than 7,000 tons of supplies were discharged through the ports during the 4-day storm. Daily discharge reached about 40,000 tons. Colonel Mays inspected the damage, greeted by tired and shaved men. He saluted each in recognition of their effort, understanding the fine line between triumph and disaster. The central section of East Pier Arromanches was badly damaged, but the entire harbor could be reused. Unlike the American artificial harbor, which has been entirely destroyed, and finally was decided by General Eisenhower on June 25th to quit with the artificial harbor and send all the pieces of equipment which could be reused to the Brits. And then General Eisenhower decided to keep just the Phoenix blocks as a breakwater and then ferry all the goods directly onto the beaches with LSTs, LCTs, and ducks. We are now reaching to Cherbourg, which was then taken on the 27th of June. And then American forces had an unlimited unloading goods daily, and the Cherbourg harbor become one of the biggest ports, like Dover, and even more in 1945 at the daily tonnage of New York Harbor. The port was finally abandoned in November 1944. The local dynamites the Phoenix blocks to try to recover the expensive metal such as the bronze, which was used for the valves, and the British Scrapper Company took all the steel parts of the artificial harbor, and then the local authorities decided to keep and work on the sunken ship, the ones we know as corncobs or rock ship, to scrap them, and with the money they built the first Arromanches Museum. Now, about the advocating of the artificial harbor, senior commanders expressed gratitude for the Mulberry Harbor. Eisenhower noted, Mulberry exceeded our best hopes. Average tonnage per day from June 20th to the September 1st was about 6,760 tons a day. His Deputy Air Chief Marshal Sir Arthur Hutter credited Churchill's persistence in pushing for the Mulberries, stating that without them, that the extraordinary operation might never have come to fruition. Indeed, the whole question of the invasion of Europe might well have turned on the practicability of this artificial harbor. All through critics questions the value of the mulberry, Australian war correspondent and historian Chester Wilmot argue they overlook the key strategic and psychological factors. Strategically, having mulberry allow planners to choose landing sites away from heavily fortified ports. Psychologically, it boosts Allied confidence, making the risky invasion feasible. Even Albert Speer, the Reich Minister of Armament and War Production, agreed, saying bypassing the Atlantic Wall with a single brilliant technical device rendered the German defense irrelevant. However, Winston Churchill's decision to invest heavily in constructions the artificial Harbour Coast is spotty after the war. The Labour Party uses significant spending on mulberries as a major argument against Churchill, accusing him of extravagance reminiscent of monarchs who ordered grand constructions. There were also allegations about the use of manpower, particularly Irish workers forced to work non-stop regardless of weather conditions, which lead the disaster to disease and harsh treatments, aching to force labor camps, like what Hitler did. Workers had limited contact with their families and faced an impossible production schedule. All through the project ultimately succeeded. Churchill was also criticized for the cost of the side infrastructures like railroads, roads, and bridges, which nearly matched the main project expenses. The poor working conditions provided further ammunition for the Labour Party oppositions and allowed Clement Attlee to take over from 1945 to 1951, and during his prime minister tenure, he expanded and improved National Health Service.